Okay, so let's begin where we left off. And I noticed in these directions up here, I put write in exponential form. It should have said all, well, I don't want that in highlighter. All answers should have positive exponents. So you want to make sure you don't have any negative exponents when you're done putting it in from radical to exponential form. Okay, we're going to do a few more of these before we move on. Let's look at the third one. So remember, these are in radical form, and we are just making them equivalent into exponential form. So we have the cube root of a to the fifth b cubed over c squared. Okay, to take this out of radical form, we're going to convert this into an exponent. So we still have a to the fifth, b to the third divided by c squared. But remember, this is really to the first power, which is the numerator. The root is the denominator. So it's all to the 1/3 power. And remember that you share that exponent to any other exponents you have in your quotient. So we get a to the 5 times 1/3 or 5/3, b to the 3 times 1/3 or 3/3, and c to the 2 times 1/3, which is 2/3. The only thing I can really simplify is 3/3, which is 1. So we get a to the 5/3 b over c to the 2/3. And we're just going to leave it in that form so that we don't have any negative exponents. Let's try another one. The cube root of p to the 4th q. So we're going to go ahead and take this out of radical form. So we're going to start with the p. It's to the 4th power. It's to the root 3. So it's p to the 4th thirds. Q. There's no exponent there, so it's an understood 1. And the root is 3. And that's all you can do. Okay, let's do another one. The square root of a to the negative 2nd b cubed. So we'll start with a. It's to the negative 2nd exponent, but the root is also a square. Remember, when nothing's there, it's an understood 2. B to the is raised to the 3rd power, and the root is 2. Right here we can simplify this. This becomes a to the negative 1st, b to the 3/2. We cannot have a negative exponent. That's going to go to the bottom. This is going to stay. So in our numerator we have b to the 3/2 over a to the 1st, which is equivalent to just a. Okay. Number 6. Let's do this one. 1 over the 4th root of p to the 4th q to the negative 8. Nothing's happening in the numerator. It's staying a 1, but I'm going to take it out of radical form. So it's p. It's raised to the 4th power. It's also the 4th root. Q to the negative 8 power to the 4th root. And we know that 4 over 4 is 1, so that's just 1 divided by p. And negative 8 over 2 is, or negative 8 over 4 is negative 2. We can't have that negative exponent, so it's coming up, and this becomes q squared over p. And that's how we will leave it. Okay, so now we're going to go ahead and do some more simplifying. And to do this simplifying, we are going to be putting things in simplest radical form this time. All right. So I'm going to say write in simplest radical form. And sometimes it makes you put it in exponential form before you can get it back in simplest radical form. And we'll see what some of that looks like. Okay, so here's our first one. So 3 to the 4th power, or I'm sorry, the cube root of 4 times the cube root of 4. when we have the cube root of 4, we end up with, remember when you had the same root, which is cubed, you can multiply what's on the inside. So you end up with the cube root of 16, and we know that 16 has a perfect cube, it's 8. And the cube root of 8 equals 2, so you're left with 2 cube root of 2. So that's very similar to what we were doing when we were simplifying radicals. Okay, let's look at some that are a little bit different, like this one. The cube root of, let me see what I want to do here. The cube root of 9 times the cube root, no, just times the square root of 3. Okay, so let's look at this. So there's a little bit more to this, because in order to multiply these, you have to have the same base, and you have to have the same root, which we don't. But we do know that we can rewrite 9 as 3 squared. So this is equivalent to the cube root of 3 squared times the square root of 3. Now we can take it out of radical form. And how do we do that? We keep the base, we take the exponent to the numerator and the root to the denominator. We keep the base, the exponent's 1 because nothing's there, the root is 2 because it's a square root. Okay, so now when we go to do this, we now have the same base and we're multiplying. That means you keep the base and add the exponents. But we cannot add fractions unless they have the same denominator. What's a common denominator of 3 and 2? It's going to be 6. So I'll multiply 1/2 by 3 over 3 and 2/3 by 2 over 2. And what do I get? 3 to the 4/6 plus 3/6, or 3 to the 7/6. Okay, 3 to the 7/6. And we can leave it like that. We can simplify it down further, but I think it wants it, well, it does want it in simplest radical form. So we can do it, and we can say the 6th root of 3 to the 7th power. So that's simplest radical form. Let's look at another one and see how some of these might be a little bit different. Okay, let's look at the square root of, let's look at this one. The square root, the cube root of 4 divided by the 6th root of 2. Okay, so we got to use the laws of dividing, and in order to do that, we're going to need the same base. So we know that we can rewrite 4 as 2 squared. So now we have the cube root of 2 squared and the 6th root of 2. Okay, well, we can take it out of radical form by writing this as 2, and the squared becomes the numerator and the root 3 becomes the denominator. This becomes base 2, it's to the first power, the root is 6. Remember, when you have the same base and you're dividing, you subtract. So now you have 2 to the 2/3 minus 1/6. Again, I need a common denominator, so I'm going to have to multiply 2/3 by 2 over 2. And this is going to give me 2 to the 4/6 minus 1/6, which equals 2 to the 3/6, and 3/6 is equivalent to 1/2. So this answer then becomes the square root of 2, which is to the first power. Okay, we're going to look at one more thing, and that is solving. If you're noticing these, that a lot of them, there's not the same thing that you can do to each of these. They're all kind of different. So I do anticipate you are going to need some help, and that you really, really need to reach out to me through Teams, and we can go over these together until you get the hang of it. Okay, so we have t minus 4 to the 2/5. That minus 3 equals 1. So when we're solving to get this variable by itself. So we've got some work to do. The thing we want to do first is get rid of the minus 3. To undo subtraction, we add. So that's going to help us. So now we still have t minus 4 to the 2/5 equals 1 plus 3 is 4. Okay, so I want to get rid of this 2/5 power. I do this by multiplying by the reciprocal. 2/5 times 5/2 becomes 10 over 10, which is 1. But I also have to multiply this by 5/2. So by multiplying this by 2/5 times 5/2, I get t minus 4. So I'm getting closer to getting t by itself. What does this equal? This means the square root of 4 to the 5th power. Okay, and we know the square root of 4. What is the square root of 4? It's a perfect square. It's 2 to the 5th power. And 2 to the 5th power is 32. So I'm going to add 4, and I'm going to get t equals 36. See how I solved? I got t by itself. Let's try another one. X minus 1 to the 3/2 power equals 8. So again, we have to get rid of that exponent, and that exponent is a fraction. We multiply by the reciprocal of 3/2, which is 2/3. We do it to the 8. These become 6 over 6, which is 1, and you're left with x minus 1 equals, this will be the cube root of 8 squared. And the cube root of 8 is a perfect cube. It's 2, and then we square it, and 2 squared is 4, and we add 1. And we get x equals 5. Number 3, and do one more. 5x to the negative 1/3 power equals 20. Okay, sorry, equals 20. So before I start multiplying by the reciprocal, I want to get rid of what's in front of x first. And how do I do that? By dividing by 5. So now I have x to the negative 1/3 power. I'm getting closer. I don't have just x, but by itself, I have it to the negative 1/3 power. But now I can get rid of that exponent by multiplying it by negative 3 over 1. Negative 3 over 1. Okay? So when I do that, this goes away and I have just x, and this is really equivalent to 4 to the negative 3rd power. Whenever I have a negative, it moves to the bottom. Since nothing else is here, that's 1 left on top. And 4 to the 3rd power means 4 times 4 times 4, which is 64. And that's your answer. Okay, so we've done a lot of different things. On this note sheet. It's a lot of information, and it's applying a lot of what we've done throughout the year. The main thing to know is this box right here. This box is so important because all you're doing is writing them in different ways. Remember, this is exponential form, and this is radical form. They're equivalent. It's just different ways to write them. Okay, so that's the most important thing to know. These laws of exponents, you'll notice we were applying these throughout when we needed different things. So we've started off simplifying by going from this was exponential. I'm going to write it right through there. And this became radical, and then we simplified it. We converted it. We took it out of exponential by writing it as a equal radical, and then we simplified. Here we had a radical, we took it to exponential, and then we just made sure all our answers had positive exponents. Here, this is probably the trickiest one right here, this writing in simplest radical form. I anticipate we're going to spend some more time doing these kind. If you notice, we only did 3, but we'll probably do more. And then the last thing, solving. These are like a puzzle, but your goal is to get that variable by itself. And you have to solve it just like you do equations and try to get that variable by itself. Okay, we're just about out of time, so go ahead and finish those notes and reach out to me if I can help you in any way.